This is a production of Cornell University.
Thanks to all our attendees for registering today for the live webinar. For those of you watching on the recording, obviously this is on YouTube, so you guys can watch on demand. This is the fourth webinar in our series related to our environmental results program. So this has been a joint effort between the New York State Pollution Prevention Institute, P2I Center, us at the Cornell Turfgrass program, myself, Carl Scamenti, and Dr. Frank Rossi, the New York Turfgrass Extension Specialist and Associate Professor here at Cornell. And then, of course, Rick Slattery, so a former superintendent at Locust Hill and a variety of other facilities. Rick's been integral in this project, giving us that superintendent point of view. And this whole project is really aimed at improving BMP adoption. So again, for those not familiar, this is kind of a four-step process. The first step being, let's really target a couple BMPs and make a survey. And the second step was to evaluate the adoption of those various BMPs in our local region. So we're looking at Central and Western New York. And so based on all that survey data we got back, we went to an outreach phase, step 3. So you can call it intervention. But this has been kind of a multi-pronged approach. We've been doing these webinars, for example. We're going to be doing a couple field days here this coming year. And we're going to have resources online. So you can go onto our website. I'll throw these links in the chat. You can find a bunch of case studies and a bunch of resources, nutrient management plan, spill control checklist. We'll talk about that today. And this infographic poster. So this step 3 process is really us targeting increasing certain BMPs that we found required improvement. And then the step 4 will be at the end of this year. We'll go back in and survey and see how we did. Did we improve adoption rates? That's what we'll have to see. So basically, we've got these 4 categories that we've separated BMPs into. And today, we're going to talk about the last one that we haven't done a webinar yet, which is pollution. And I think the P word, maybe people in our industry don't like to say it very much, pollution, but we're going to talk today a little bit about the perception and the reality of pollution on golf courses. So as you guys know, the public doesn't necessarily view golf courses kindly when it comes to environmental concerns. You can just do a simple Twitter search or recently a CNN article with a pretty inflammatory visual there on the front of it, right? A golf ball in a hellscape. I think that represents, the general public view of golf courses, that we're applying all these chemicals, and sometimes you see that bleed into some potential policies. So, for example, in New York, this didn't go through, but proposed legislation that I would say is questionable. Is that going to actually help the problem? Do they understand really what's going on golf courses? So the reality is that in the last 2 decades, we've been decreasing our fertilizer use. This is data from the GCSAA that's showing significant decreases in nitrogen, phosphorus, and potassium use. And the other thing is looking at pesticide use on golf courses. This hasn't been something you can really find in literature anywhere. Frank and I were fortunate enough to partner up with some folks at University of Wisconsin and kind of look at pesticide use on golf courses and compare that to other land use types, right? So when people say, oh, that golf course is using too many pesticides, what would that turn into? And maybe that land use type may use more pesticides. So for example, in our research, if we normalize all the pesticide use on 180 acres of a golf course property, the EIQ, this is a way to model pesticide risk, is in the 200 range. When you compare that to something like an apple orchard, vineyard, or a potato farm, it's actually substantially less. So this is just, again, kind of putting into perspective the amount of pesticides we use. We're generally treating down the middles, right? Tees, greens, some of us are treating fairways, but there's a whole lot of peripheries of the golf course that aren't receiving chemical applications. And I think this sort of research gets us closer to people understanding that. So at the same time, we're using less fertilizer and less pesticides every year, but there is going to be some that leaks out to the environment. So a really cool meta study from the folks at Virginia Tech, Bach and Easton. We're going to lose some nitrogen that we apply. We're going to lose some phosphorus that leaches. And when you look at our golf course water bodies, again, this is a meta study from from 2010, looking at a bunch of different other studies measuring water quality on golf courses. We got a pretty high percentage of our waters that have elevated levels of nitrogen. Most of them have elevated levels of phosphorus, but pesticides, not so much. So there's a little disconnect there. We've got a lot of nutrients, not a whole lot of pesticides in our water, but there's reasons for that. So the first reason is legacy nutrients. We saw that graph earlier that we've reduced fertilizer use over the years. A lot of those nutrients are going to be in the system for a long time, and they're going to continue to leak out long after we've applied them. So even though we're reducing nitrogen and phosphorus rates now, there's still some left in there, and it's going to make its way in there. But the other key thing about golf courses is they tend to be the collection area of watersheds. So this is an example here at Cornell University. So obviously there's the golf course. We have 2 golf course greens here near a water body, a little pond here on our 5th hole. But the other important factor here when we see eutrophication in the summer is to consider that there's a horse farm here upstream. And when we get heavy rainfall events, water gushes across that horse farm. There's manure, right? And that ends up in the water body. So when we test golf course water bodies, it's important to consider what's the total amount of water that's coming in there. And a lot of times it's coming in from other land adjacent to the golf course. So the way you can combat this is with BMPs. And the first one is basic structural BMPs, planting vegetation around these water bodies. A growing longer grass, you can see in this image, longer vegetation that slows the runoff rate, allows infiltration, and can filter out those pollutants as you're slowing that water down. So just an example here in Kansas, right? Implementing these BMPs reduces nitrogen in the water, it reduces phosphorus, reduces herbicide degradates we see in there. And it starts to improve some of the macroinvertebrates, species enrichment. So these sort of BMPs work, and it's really simple, long grass, right? We can think of it as just longer vegetation. Again, it's about slowing the rate of the water going to that, in this case, this is a stream here near Montauk, at Montauk Downs, slowing that water, allowing the vegetation in those root systems to filter out those pollutants as they go in there. And these images are courtesy of Rick Slattery, who did implemented a lot of these long grass areas at Locust Hill when he was the superintendent there. And they obviously look beautiful, and there can be strategic elements to them. And this is kind of what it looks like before, right? And I think there's a lot of golf courses that have these, I would call them peripheral areas in between 2 holes, in between car paths, great candidates for long grass conversion. And it's super simple. Rick, documented it well here with photos, lining it out to start, allowing it to grow up. In the course of the first year, maybe you make an herbicide application just to control some weeds, but this is in August that same year, and you've already got a really cool long grass area. It does more than just filtering pollutants and runoff. That's what we're talking about today, but carbon emission savings, right? You're mowing that area less. You've reduced your time to manage that area. You can reallocate that labor elsewhere. Biodiversity, right? You've got longer grass in there. You're going to have some smaller animals running around. You're going to have pollinators, probably, if you have flowering weeds, or flowering vegetation. So it's good for those environmental purposes. And if you're a golf geek like me, there's strategic implications to long grass for good players. And also we call it vertical scale. So a lot of times architects will talk about playing corridors left to right, the scale of a golf hole, but that also pertains vertically. So longer grass gives that vertical element. It's like topography, it's like bunkers, it's like trees, getting your eye to go up and down. So there's some golf reasons to do it. But if you'll notice, we have up here in the top corner, this is an eagle. And if you followed our program, we have these BMPs as par birdies and eagles. And eagles are kind of the ones that we've deemed most difficult to achieve. And so you're probably wondering, well, hey, you just told me it's super easy to put long grass in. Why is it an eagle? And it's because we have golfers. Long grass equals golfer disruption. And I'm sure some of you watching this have had times, if you've tried to create long grass areas, a golfer comes up to you and says, I hit my ball, I couldn't find it in there. I don't like that long grass. So the reality is that we have golfers, we have greens committees, GMs who will ask us these questions about, we don't want to lose our golf ball. We don't want to have slow play. So you have to think about how you balance these reduced inputs, the environmental benefits of long grass with golfers actually recreating on your landscape. And you can do that through data. And this is some really, really cool data we did for a case study in this project. We partner with the USGA and their Deacon system. And through this system, you can get a service where you hand out GPS data loggers to your golfers. And this is an image of our Cornell golf course where each time you hand out that logger, it tracks their location across the whole golf course. And you can generate maps like this. And this is great for a whole bunch of reasons. But today, what we're talking about is long grass. And one of the case studies that we looked at was identifying areas on the golf course, these peripheries that have low traffic. So we're seeing a bunch of large areas where, maybe we have one or two golfers coming in there, but we measured 185 golfers. So this gives us really good data to go in and you can advocate to your GM, to your greens committee, hey, we're seeing less than 1% of people go in these areas. It's 2 acres, it's 3 acres. We could save a whole lot from reducing mowing in there, and we can have these water filtration benefits as well. So you can find that case study online. I'll drop a link in the chat below here in a bit, talking about the things we quantified in that case study. And I encourage you to check out that Deacon system. It's good for a lot of reasons, but this is what we focused on here. So all of these things I'm talking about are really about non-point source pollution. And what that means is you can't point to the spot where it's coming from. It's a landscape scale. And there's these structural controls we can use around water bodies, right? Longer vegetation, detention areas. Those help reduce non-point source pollution risk. And then, of course, just reducing your chemical use, right? Less fertilizer, less pesticides are really the 2 ways you're going to prevent non-point source pollution. But then there's point source pollution. And as I transfer over here to Rick Slattery, who's going to take us the way the rest of the webinar, point source pollution, as the name suggests, is you can point at it. And on a golf course, where you're generally going to be able to point to pollution is the maintenance area. So happy to introduce Rick Slattery, former golf course superintendent. Rick, you're going to walk us through a bunch of BMPs today relating to that maintenance facility and how you can reduce point source pollution.
Thank you, Kyle. And I'll start with, I'd like to just start with some overall comments about the maintenance facility in general. And as part of our ERP program, and it's on our ERP poster, that we do have a pro tip there that a well-kept maintenance area reduces risk, and it speaks volumes about your attention to detail. And I'll share with you something that happened to me early in my career when I was, trying to climb the ladder and trying to move on to better clubs and that kind of thing. And I had a visit from a greens chairman from a very prominent club in town, and he wanted to come to the maintenance facility. And so when he got there, I asked him, why'd you want to come to the maintenance facility and not meet at the clubhouse or, offsite or something like that? And he said that in his experience, there was a direct correlation between the upkeep of the maintenance area and the upkeep of the golf course. And he said he could tell how well I was taking care of the golf course by just looking at my maintenance facility. And it kind of made an impression on me. And, I think throughout my career, I started looking at things a little differently. And when I was at Locust Hill and we were hosting the LPGA one year, I did ask the LPGA officials if they saw a correlation went on tour, from golf course to golf course, because they saw so many golf courses. And, was that true for them? Did the maintenance facility, how that looked, did that kind of correspond with the golf course? And they verified that. And they said, yep, that's, we do see that. And so the advice I would give is to take as much pride in your maintenance facility as you do your golf course. And you can tell by these two the before and after pictures here, if you were a member or a golfer walking into your facility, which one would, give you a little better impression about the way things were run. And so when I got to Locust Hill, I inherited a barn floor here. And it was, when I inherited it, it was unpainted and it was splintered and just all beat up. And you know, you can see that it's amazing what a floor sander and some epoxy can do every year with the floor and first impressions. And you know, our shop was used to house LPGA players during rain delays, and officials and everybody would kind of come in there. And you know, when we had rain delays. And so you know, this floor, we got a lot of good compliments on it, and I think it gave a good impression to the players on the tour of our facility. And you know, I once worked out of a barn with no bathroom, but we always kept it neat and clean and well organized. And whether we like it or not, first impressions do matter. As a par on our ERP poster, we about floor drains here, and just my advice would be know where your floor drains go, if anything, for liability reasons. During at Locust Hill, we had quite a few environmental and insurance audits, because we'd be doing something in the clubhouse or changing insurance companies, and I'd have an audit or somebody come in and do an inspection. And I can tell you, the first thing they always asked me when they walked into my shop was, where do the floor drains go? And I have to tell you that the first time that happened, I was a little embarrassed because I didn't know. And I can tell you that we did find out. We traced them after they left, and a couple of them were going into an old abandoned septic area, and we immediately got those plugged up. And I can tell you another time I had a pesticide inspection from the DEC, and they walked into my pesticide room, storage room, and we had a drain in there with a, you know, crock, so that if we had a leak, we could pump the chemicals out. And that was what they asked me first thing: where's that floor drain go? And as soon as I told them it just went to a crock, you know, they were fine with it. So again, my advice would be to plug any floor drains that you have that might not go into a holding tank. And the reason being, we want to try to avoid situations like this. And you know, this is I know a lot of superintendents in my career that get themselves in a little bit of trouble, and a lot of times it was just because of the dye that was in the tank. You know, you rinse your tank out, and you know, the dye goes into the water and goes behind somebody's house, and they see the dye, and all of a sudden they're all up in arms about it, and you can get in a little trouble. So an out of sight, out of mind attitude with some of this stuff can get you in a lot of trouble. So if you can't plug drains, what do you do? One thing you want to do is just make sure you daylight them a sizable distance from the property boundaries, water bodies, or any natural vegetation border before they can get into the water. If you do have a spill on site, we developed a spill control procedure as part of the ERP program. It's on our website. The website's listed right there below on the bottom left-hand side. And we had this vetted by some people at DEC and the people at B2I, and this is what we came up with. And you know, again, go on our website, print this out, put it up in your shop somewhere, and make sure your staff is aware of it and knows what to do in case there's a spill. So what would be around the shop? What would be our biggest source of pollution? And a lot of fingers can be pointed right to the equipment wash area. And you can see right here, just by this picture, how much clippings and how dirty the water rinsate is coming from the equipment wash operation. And in 2014, Locust Hill was certified by Audubon International. And during that process, they identified a gap in our sustainability efforts because we didn't have a closed loop wash system. And you know, I explained to them that the major barrier to this is the cost. A lot of these commercially designed systems can be $40,000, $50,000, $75,000, depending on what you decide to get. And so it wasn't too long after that I was contacted by the New York Environmental Leaders Program, and they had seen we were certified by Audubon, and they asked us if we wanted to join the program, which we did. And the first thing they asked me was, how can we help you? Was there anything we can do to help? So I mentioned this gap in our sustainability efforts and about the wash pad. And so that's when they introduced me to the people at the Pollution Prevention Institute that's located at RIT in Rochester. And They are a friendly arm of the DEC. They voluntary compliance. They're there to help businesses, help them become more efficient, help them with any kind of environmental problems that they might have. And they supply the funding. And I can tell you, here's the contact information. Eugene Park, if you want to get a hold of them. And like I said, they're very helpful people. I've been working with them for about 6 or 7 years now, and they're a lot of fun and just real good to work with. So P2I decided to take on the project, and we set up some goals. First, we wanted to clean the water of pollutants. We wanted to reduce water use if we could. And the big thing was we wanted to develop a system anyone can afford, not to replace the commercially designed systems, but as an alternative for people who where you might have somebody breathing down your neck and you just can't quite afford to put a big system in there. We wanted to devise something that you could go to. And also we want to minimize the time needed for maintenance. Nobody wants to, no superintendent wants to spend a lot of labor out at the wash pad. So the first thing we did was we put in a couple GPM meters on our wash hoses, and that helped us track the amount of water we were using. And with the idea that we wanted to get the amount of water we're using as small as possible so that we could keep the system that we designed small. And by keeping the system small, that would keep the cost down. And if you're interested, you can buy one of these GPM meters for anywhere between $20 and $75 on Amazon. It's really not a big investment. The other thing we did that we started doing to try to reduce the amount of water we were using, it was blow off our equipment with air first. And we actually found that it reduced the time that we were spending washing off equipment, and it actually reduced the water by 50% that we were using. It extends equipment life. During the surveys that we did, I visited one golf course with the superintendent. All he used was air. And he just pointed to the fact that his equipment lasted longer. It was a mom and pop operation, and seals, bearings, all that stuff just lasted a lot longer. And I can tell you from my people, they prefer staying dry. Go out there on a 50-degree day or a 60-degree day and start splashing water around for half an hour, and it's not a lot of fun. So there's different things you can use. A compressed air here. We had a compressor in our shop, and all we did was hooked up a small PVC pipe to it and ran that out to the wash area. And if you don't have anything like that, you can always use a backpack blower. The guys that were on our bigger equipment, like our fairway rough mowers and big fairway mowers, they actually liked using the backpack blower before they washed it off. And the second thing we found was just don't use open-ended hoses, just by putting a nozzle. And we found this at a hardware store, very cheap. I think it was under $10 or $15. And you can see here by the GPM meter, which it's using a little over 6 gallons per minute. But just putting nozzles on the hoses, we were able to save another 30% as far as water goes. And then of course clipping control. You have to have a way to be able to control those clippings. We had at Locust Hill wash pad here. This was put in, maybe 1990 or so. And you can see just by having some screening here in the trough, how well that does in cleaning a lot of these, clippings out of the rinsate. And any kind of a system you put in, there's going to be some manual work with just getting the clippings out of there and collecting them and then composting them or spreading them out afterwards. And some of the surveys that we did, fellas were, which is an alternative option. They were washing or blowing their equipment off at multiple sites around the course in the rough, away from water bodies. And that's okay if that's it's a lot better than just any other option that they have, but it's a good option. So what did we learn during the feasibility phase? Using compressed air to blow off equipment before washing reduced water use by 50%. Using compressed air also reduced the clipping content in the wash rinsate by 50%. Installing low flow nozzles on wash hoses reduced water use by another 30%. Installing water meters provided valuable data on how much water was being used for the wash operation. And water doesn't have to be perfectly clean to wash equipment. That's one thing we found, was you really don't need drinking water to wash off equipment. So if the system that you're using is not perfect, that's okay. I mean, the water doesn't come out perfect. That's quite okay. And just simply using air before washing, using low flow nozzles, and collecting clippings, just so if you just did those 3 things alone, that would make a huge positive environmental impact. Decision was made from there to enter phase 2 and design a prototype going forward to see if we could do that. So again, some of the considerations was know the flow. This goes back to the GPM meters again, knowing how much water we're using so that we could size the tanks in the system. And obviously less water means smaller tanks in a smaller system and less cost. Another consideration is you're going to need some kind of wash pad and trough, and then just for collecting the clippings. If you put any system in, whether you put a commercial system in or whatever you decide to do, you're going to need a wash pad in some way and a trough to somehow collect those clippings. And you can see the screens that we had installed, and that's just sheet metal with a bunch of holes drilled in it. And as the as the clippings built up in front of the screens, we just take a shovel and a rake there that you see and clean out in front of those screens. The other consideration is electricity. You're going to need some electricity to run some of this equipment. So we actually installed ours in-house and off this telephone pole here. But that's something you've got to consider. You're going to have electricity somewhere near wherever you put a system in. So this is the basic system, and this is an Eagle, as I said, just blowing off equipment and doing nozzling and collecting clippings. Those are the things we would recommend doing first. And then as you move towards much better arrangement, then you can go to these closed loop system. And this just shows the basic components. In the bottom left-hand corner, you see this black hose coming out. That comes from the trough, pumping the trough, goes into the sand filter here. This is the major component of the system. And then for our system here, we had to have a transfer drum, and the purpose of that was just to pump water from the bottom of the sand filter into the top of the storage tank. And then we had a booster pump out here that would pump water out of the storage tank and into the hoses that we would use for washing off the equipment. And as I said, a lot of this was just to create an awareness of the situation in the first place, of how bad this stuff is that we're injecting into the environment. Locust toes, and on a good mow day, we were generating about 1,700 gallons of water before we started with this project of that rinsate out into the environment. And then to provide an alternative to the expensive systems. If you can afford an expensive system, fine. But as I said, if there's people breathing down your neck and you don't have the money, this is an alternative. And we can, as we go along, we just want to show the results of this system through the water testing here. This is a sample of water from the wash pad itself, and you can see before it even entered the system how nasty that stuff looks. And then we had a Hydra Screen set up here that basically it's like a washboard. The water goes into the bottom and it fills up the back, and it kind of runs down the front, and the water goes in, and the clippings kind of stay up on top. You can see after running it through the Hydra Screen, there was a little bit of an improvement, got some of the solids out of there. And then it's transferred to the top of the sand filter, which is the key component of the system. And you can see that water coming on the third bottle here, the water coming out of the bottom of the sand filter is a little cloudy or a little when it comes out, but it's much cleaner than anything than when it came in the top. This is a good point to just show very quickly the construction of the sand filter. We started with a 1,600 gallon tank here. And from that, as you look over to the top right, we had just a PVC pipe running across the top of the tank with some holes drilled in it. And that would accept the water from the pump. The pump would, from the trough, would pump into this. and then these holes would sprinkle out the water on top of the sand. The water would go down through the sand, and then down in the bottom here, we constructed what we call a lower manifold, just an X, same thing, PVC pipe with some holes drilled in it, and then we covered up the pipe with drainage stone. And over in the bottom right here, you can see the results with the water coming out of a spigot that we installed in the bottom of the tank. And then from there, we had the challenge was, how do we get the water from the bottom of the sand filter up to the top of the storage tank? And basically, that's where this transfer drum, this blue drum, comes in here in the middle here. And the hydraulic head basically moves water down through the sand filter. So this pipe here, it's horizontal, that determined the height of the water in the sand filter. So obviously you raise this up, there's going to be more water in the sand filter, lower, and there's going to be less. So as water here is pumped in through the upper manifold and is dropped onto the sand, and water fills up the tank, the head pushes the water out to this level here and into the transfer drum. From there, inside the transfer drum, there's a float and a sump pump inside here. And as the drum fills up, the pump kicks on and pumps the water to the top of the storage tank. And then inside the storage tank, we had another sump pump operating, just circulating that water on the inside, keeping bacteria from building up inside the tank as it sat there waiting to be used. And as you can see here, again, these are the water samples that we took. And that first bottle is before it even entered the system. You can see how nasty that looks. And then as the water settled out in the holding tank, in the storage tank, that last bottle pretty clean and looks pretty good. So it proved that we were successful with getting the contaminants out of the water. And here's some of the water test results we had from Locust Hill. And you can see the bacteria concentration in this first column here, 20,000 here after the Hydra Screen. And the water after the sand filter, the sand filter just drops it down almost nothing, 200. And then the hose out was 2,200. So that proved to us that we were getting a little bacteria building up in the holding tank as it sat around. And you can, add a UV light or some chlorine tablets if in extreme situations. But you see how the turbidity dropped quickly. COD measurements dropped from 70 just about down to where it was safe to drink. But we never found any volunteers that wanted to give it a try and give it, drink a cup to see if anything would happen. So, and the cost of the system, we were able to keep it down quite a bit. You can see it was about a little over $5,000, but that does not include the concrete pad or the electricity. And if you have tanks lying around, we got one of ours from a old fertigation abandoned system. And, you can even drop those costs down even more, because you can see that the tanks are probably the most expensive part of the system. So if you can eliminate that, you can almost do this for nothing. So what did we learn from to improve wash pad system 1.0, as we'll call it? We decided to locate the sump pump in a wash pad trough inside a crock with a float, so that it would operate automatically. And I can show you a slide of that in a minute. And we also wanted to look into locating the bottom of the sand filter above the top of the storage tank, so we could eliminate the transfer drum. And this would also keep the sand in the sand filter dry, which we're hoping would require less maintenance overall, and possibly regrading of elevations. And then also you could use a storage tank that's much shorter in height but larger in diameter, and that can help you achieve the same thing. And we discovered the Hydra Screen is a little finicky and requires some ongoing maintenance as it's being used. So we want to look into ways to improve the screening in the trough, to remove clippings more efficiently there, so we wouldn't need the Hydra Screen. And a circulation pump in the storage tank limits buildup of contaminants while the water is stored for use. One thing we thought of doing was just install a light sensor to turn the pump on and off automatically, because it really doesn't have to run 24 hours a day. It would be off during the day and on at night. And as I said earlier, extreme conditions may require the addition of a UV light or chlorine tablets to the storage tank to keep that bacteria buildup down. And we also found that the system was capable of reducing water use by 80 and 90%, and that's dramatic, I think. So then we moved on to Wash Pad System 2.0, and we were very fortunate that a famous golf course on Long Island, I won't say who it was, they have 90 holes and 5 courses. They stepped up to the plate and they partnered with P2I to build the 2.0 version. And they were so successful with that they have more planned in the future. And this is a schematic that we put together to kind of show the differences between Wash System 1.0 and Wash System 2.0. First of all, over here, we wanted to try to improve the screening in the trough so that we could possibly eliminate the Hydra Screen. Again, I'll show you a slide on this, how the difference is, but we also want to install a crock so that we could put the sump pump in there and with a float so that it would operate automatically, wouldn't have to turn it on manually. And from here, this is the big difference where you pump to the top of the sand filter. And here the sand filter is located above, the bottom is located above the storage tank. And here the wash system here is, the sand filter is located on the same level ground. So as again, you can see that this pipe here, this horizontal pipe determines the water level in the sand filter. And the sand in the sand filter on this wash system 1.0 was always staying wet, which we felt added to some of the contaminants that would stay in the system. Whereas wash pad 2.0, the sand is always staying dry, because immediately when the water gets to the bottom manifold, it goes out and drains directly into the storage tank. So eliminating this transfer drum by just elevating this the sand filter, I think is a big improvement and going forward. And here are some photos of what I'm talking about there. And again, the location of the tanks, these are on level ground here in 1.0, the top left-hand corner. This is wash system 1.0, and this is the transfer drum. And with 2.0, you can see they located the sand filter above the top of the storage tank. So you can see this pipe here. Immediately when the water goes through the sand filter, it's draining off into the storage tank. This is just a side view to show you the same thing. And here on the left is wash system 1.0 with the screening we had. You can see it worked quite effectively and worked well for us. But we also had the pump. We did not have a crock, so the sump pump was set down in here. We took the grate off and set the pump in here. And as the trough filled up with water, then we would turn the sump pump on manually. And as it got pumped down, we would turn it off again. So that was something we wanted to try to improve upon, which with the 2.0 version they did. They added a crock in here over here at the bottom. They put it in a crock and with an on-off float. So that part of the system operated automatically. They also improved the screening out here in the trough. They used some chicken wire with some other items, and they were able to eliminate the Hydra Screen. And then here is just to show you real quick the booster pumps with 1.0. We had a little larger booster pump. We supplied 2 hoses on off, and as you get draining, as you turn on a hose and downstream, you start losing pressure. This pump would kick on and supply the hoses with water. And with 2.0, they actually over here on the right, they started with a pressure washer. And you can, for smaller operations, you can just go down to Home Depot or somewhere and pick up a cheap pressure washer to put on there. But they did find out later on, they did upgrade to a booster pump here, and they did find that increased the efficiency of the washing of the equipment, and they were able to get it done a lot quicker. And this is some of the water tests we had from Wash System 2.0 that came in. And you can see the COD measurements. Pre-treatment, 1085. After the sand filter drops dramatically, it's down to 67. And the water coming out of the power washer was a 6. So some huge dramatic effects there. And just to give you a quick comparison, municipal wastewater can run between 300 and 1,000, and unpolluted surface waters are less than 20. So big improvement there with cleaning the water. And you can see that this is what their system cost them. And it's, again, it's down there just over $5,000. They had some wood here that was involved just to make it pretty and build some stands and things like that. So you subtract the wood from the total, you come out with a little over $5,000, which was what the wash system 1.0 cost. And again, if you have tanks laying around or other ways that you could put in some tanks, that you could save a lot of money there. And like I said, almost do this for nothing. And just as a note, the concrete wash pad costs them about 10 grand. So depending on the size and how elaborate you want to make it, you could, you're going to spend 5 or 10 grand just for the wash pad. But again, even if you were to put in a commercial system, you're going to have to put a wash pad in to collect the clippings. And their electrical wiring costs about a little over $2,000. Again, we did ours in-house for 1.0 and it didn't cost us anything. So what are the questions moving forward that we want to do? We want to, for 3.0, which we do have planned for next year at the same golf course. How small can the sand filter be given water volumes? Again, can we make the system smaller than we're making them right now, and still have them still be efficient? How long can the water be used before recycling it to be replace it? And we have been experimenting with harvesting rainwater. And during the rainstorm, the wash pad and the trough will fill up with water. And we found that you could pump that into the system and just replace anything that you might have lost to evaporation or whatever. And almost be self-sufficient where you don't need any municipal water at all. We're hoping where you can just replace anything that you lose with rainwater. And then how much difference does actually elevating the sand filter make to the maintenance of the system? So we want to look into that a little further and to see if elevating that sand filter and keeping that sand dry, how much does that actually make the system much more efficient or not? And then we want to look into the optimal sand type for filtration. And what properties of sand actually would work best in this situation? Right now, we're just using top dressing sand that we have on site, and it's been working fine. But it would be interesting to find out if we have a sand that would work best. So with that, I'll stop sharing my screen and go back to the panel here, and we'll proceed from there.
All right, thanks, Rick. Frank, we'll bring you in here, and we want to get your quick thoughts on when you see all that. Just some quick thoughts from you, and then maybe questions you have for Rick and things that we could talk to our audience here about, and try and get them to think more about putting these types of systems in.
Yeah, no doubt. So great to hear from you guys. I want to start with both of you. Carl, you gave the information about long grass, being an eagle, showing the deacon approach. Rick, you did this. Can you talk about the first steps you took in trying to establish these long grass areas that might give a superintendent some practical tips to just, how do you start? I'm not getting deacon. I'm not doing a GPS. How do I start figuring out how to go about this?
Oh, unmute real quick. Yep, there you go.
First, it starts with the educational part of this. You want to, whether you have owners or membership or whatever, you want to start communicating the benefits of having these areas on the golf course. I always felt that they added depth to the golf course. That was the word I always used to use. But I can tell you, it was a little the first time I did it, I just went out and picked the areas and without much thought. And we ended up cutting a lot of them down because they were in play areas, the couple that, and so I lost some momentum on any momentum I had in establishing those. And then later on, when we decided to become certified by Audubon, that was one of their requirements. And so we just started small, and that's what I would tell anybody: start small. Go to these areas that are really out of play. I mean, where there's no chance of a golf ball going in there, and just start start there. And then as they became more popular and people started catching on and other golf courses were doing it, I was able to develop more and more areas and add to that. But I would always say that up here is it depends on what you want too. If you want a perfect fescue, maintain, whatever, it's got to be this or that or wispy. You can get into a lot of maintenance with these things. And the bottom line is, when I started with mine, I got the best results by not mowing it all in the spring. Don't touch it in the spring at all. And we just mowed it once in the fall and maybe sprayed it for weeds in the fall, and that's all we ever did. So, but I would just say start small. Even if you start with these vegetation borders around your water bodies. I started just by going down to the water first. We would fly mow. Now, what superintendent wouldn't like to get rid of his fly mows and hang them up, not use them, especially in this day and age of labor. Labor is so hard to find. At Locust Hill, I had to send four to five guys out for 8 hours to do all that fly mowing around our water bodies. Now, not only is that a lot of labor, I could use other means, but we were putting all those clippings into the water, getting algae blooms because of it. So I started just going down to the water's edge and letting the aquatic weeds kind of come up a little bit. And then just slowly, every time we fly mowed, maybe come up a couple inches, then another couple inches, then a couple of inches. And I got it up a certain depth, and then I could almost see where, golfers started getting a little uncomfortable with it. So we stopped. But a key to that is to keep the weeds out. The members and the golfers don't like the weeds. But I guess my advice would be to start small and start out of the way, and don't go big, right away. Just start small.
I guess the other thing I'd ask is, the question I get a lot is, okay, I can do this buffer around water, and it's a no spray zone. So what do I do there? What happens when weeds come? What are the management? Okay, not mowing, and you learn pretty quick how many weeds mowing actually controls, because you start to see plants in there you don't normally see. Now, in the last bunch of years, we've been able to transform the perception of milkweed from a weed to a we got to have milkweed for the monarchs. And so my question is this, Rick: how do you manage a no maintenance zone, a no spray zone around these water bodies without a little bit of spot treats? How do you go about managing 25 to 50? And if pesticide labels are followed, 100-foot borders around water bodies?
Yeah. Well, I could tell you how I did it, and people, it's amazing when you think of something, it might be overwhelming at first, but I would just send some guys up there when like I said, the grassy stuff and the low growing stuff, even clover and stuff like that didn't bother people too much. But it was when you get the goldenrod and things like that, these big long stemmy things would come out. And I can tell you, once a month I'd send a couple guys up to the edges of the creeks and the ponds and just pull that stuff out manually. And if you look at that, and while I was spending 4 or 5 guys and 8 hours a week to trim this stuff, what is it to send a couple guys up to there every once in a while to just pull some of the unsightly weeds out? Now that worked for me, and but that's something that I would say. I mean, but that is a it's a BMP, and we got to learn how to figure it out. And as you just mentioned, we're seeing a lot of the new chemicals are coming out with this. We say this all the time. It's like, well, we're trying to tell you this stuff so that you'll know about it and you can kind of prepare for it and kind of get ready for it. And what do? We wait till it's legislated. And what's happening is all the new chemicals are coming out with that 100-foot no spray zone around water bodies, and that's how they're getting around it. So we could do it voluntarily, or we can wait until every label we're using is listed like that. So you got to figure it out. But as far as weeds, you know, just a couple guys going up through once in a while was a lot less labor than trying to trim those things every week.
Carl, what about from a golfer's perspective? You're our guy here, and certainly Rick, before he threw the clubs away, was quite the golfer. But from a golfer perspective, you know, I know you're play the course as it is, right? No matter how bad the bunkers are, sometimes that's an inside joke. If you know, you know. So how do you think about these things from a golfer perspective? Because you're right, and Rick mentioned it. It is a bit navigating around play without data, just as a golfer. How do you think about these things when you see them now?
Yeah, I think the prevailing view is that golfers, so for example, they see long grass on TV, whether it's at a place like Bethpage, at Shinnecock, at the Open Championship right across the ocean, and they see players who find their golf ball and can hit their golf ball out. Now, there's a couple of things there. One, those courses, they do manage those areas, and whether it's herbicides or growth regulators, but that's championship level conditioning. They need to be able to find the ball, keep it wispy, keep it thin. At most of the golf course we're targeting, that's probably not feasible. And so the first thing I'd say is you have to communicate expectations to golfers. You know, Rick, you were talking about, you know, don't mow during the spring. So there'll probably be a 1 to 2 month period where golfers will find their ball where it hasn't really hit that lush growth yet. And there may be 1 or 2 months in the year where it's just going to be hard to find your ball. Now, what I've talked to, you know, our director of the New York State Golf Association about this, and he recommends putting a red line around those areas and treating them as hazards. That way, if you don't find your golf ball under the rules of golf, you can take a drop right next to the long grass area. You don't have to walk all the way back to the tee because you didn't find your golf ball. So that's what he recommends. That's what I would say too. It's a lot easier to, if it's a thick area, keep people out of it, keep people walking around. We have milkweed. We'd like people not to trample that in some of these long grass areas. So when it gets really thick, you know, you can label it as a long grass area. You can have that on your scorecard. Local rule: long grass areas play as a penalty area. So that's what I think from a golfer's perspective. I will say one of my good friends says that if there's long grass on a golf course, he expects to find his ball 100% of the time. That is not a reasonable expectation. I can't recommend that to anybody. You should not expect to find your golf ball when you ever hit it.
Okay, and let me just add, and this is so brilliant, Carl. Thank you for ending on that, because try as we might, what I would say is if you can stop 20% of the people from going in there, you're going to keep the pace of play going. The problem is my father-in-law doesn't care if he finds his ball. He finds 5 other people's balls when he goes in there. So that's, you know, a good note to end on. Let's move to the wash. Let's move to a couple of simple things, fellas. I just want to draw some attention to some things you said. The drains, okay? What's with the drains? If anybody listening, watching the video, Rick, did you have drains, and how did you handle them? And when you went and visited places recently, are people always aware of the drains that they have, or is it like, oh yeah, there's a drain there, I never thought about that? What is it?
I think it's a combination of both. I mean, I think you heard me say that the first time I had a insurance auditor come in and he asked me where my drains went. I didn't know where they went. I admit I had not given it a thought, and I was embarrassed. And so when he left, I made sure that I found out where they went and everything like that. But it's so simple. We have it as a power on our poster. It's such a simple thing to do. Just know where they're going. You know, if it's daylighting out there, like one of those photos into a stream or anywhere, and you don't know that, I mean, that is something you should know, at least that's potentially could be a liable situation. So unless it's going on in some kind of a holding tank, it's so simple. You go down to Home Depot, pick up a bag of cement, and you plug it up or whatever you got to do. But again, I mean, it's a very liable, potentially big environmental problem that can be solved very easily just by figuring out where these things.
Let me ask you, you said something that, boy, I've not heard before, but I don't know why I've not thought of it before. You said an insurance person came by and asked you about it.
Yeah.
Is it common in your experience that insurance people walk around maintenance facilities looking for these kinds of things. I didn't necessarily think it was particularly common, but boy, wouldn't that be great if you could get insurance premiums lowered because you did these BMPs?
I think so. I think that's a possibility. But what it was whenever we changed insurance companies, the new company would send over an auditor and go through the whole club and look at possible liable situations, obviously, to establish your insurance rates and see how much liability they were taking on by bringing you in. And also with the tournament, I mean, I had a couple people from insurance, during the LPGA that stopped in to check things out. And also, whenever you do a project at your golf course, they want you to do an environmental review study, and that's part of it. They're going to come down to your shop. They're going to look at how you're storing your pesticides, which hopefully all of us are storing most of them off site now and just bring them in when we need them. But it was a shock to me. I mean, when this fellow, he was we were changing insurance companies, and he walked in. First time, it was early in my career at Locust Hill. He says, "Where do your floor drains go?" And it scared me, and I kind of, and it kind of embarrassed me. And, but yeah, I mean, it's such a simple thing, and it's just to create that awareness of everybody should know where these things go. And if they don't, if they're daylighting or going out in the environment somewhere, you got to get them plugged. It's a huge liable situation.
All right, one more thing, because we only have a few more minutes, and I want to make sure I get this question asked. We don't have to get the water completely clean in a wash system. And the Hydra Screen tends to be a pretty expensive implement. It looks like in 2.0, Rick, what happened at that very famous golf course on Long Island that we work routinely with was able to do. Got the water almost as clean as the Hydra Screen you had up there where you were. But before that too, I know you did a couple of things that I want to make sure you talk about again. How much water you use, blow the equipment off, find a nozzle that works, that doesn't waste water. Those three things seem to me to be the front line. And then it looks like the screen thing doesn't need to be as expensive to just clean it out a little bit. Can you talk a little bit about that whole process of saving a little bit of, big things like getting the clippings off and then cheaper ways to screen it?
Yeah. Basically, as we went through our project, and if you look at our ERP poster, the easiest things to do are to just blow your equipment off first with air, and then to put a nozzle on your hose and to try to collect the clippings. And so if you can do those three things, or even just the first two things, just blow everything off with air, and then put a nozzle on your hose. Those things there can make a huge impact. And then as I said, the Hydra Screen, basically we were trying to look at ways that possibly we could screen the water before it got into the sand filter. That's all it is that the sand filter holds up much better. There is a little bit of a layer that will form on top of the sand, so you got to scrape that off, maybe once a month or something like that, but it's very minimal. But we were just looking at ways to keep that the quality of the sand and the sand filter as good as we could for as long as we could. So the better you can clean the screens out of the water before it goes into the sand filter, the better off you are. And so we pass that information along to that famous golf course that you work with. And, so and it's about a $1,500 cost for the Hydra Screen, that if you can do that down on the pad or something like that with some chicken wire or some sheet metal with holes in it and things like that, then, then you could eliminate the Hydra Screen itself. So, but, overall, I think like I said, if you got a couple tanks laying around and you've already got a wash pad or a trough where you can collect clippings, I mean, you can do it real cheap. And it's really for the guys that, you got somebody breathing down your neck. Maybe a lot of this stuff is local municipalities now. They'll come looking at you. We had a situation where, we were daylighting ours quite a ways away from our property lines, but it was adding water, and there were members, some of the people had some drainage problems because of it. And also, as much as before we had the closed loop system, there's the smell of the degrading, clippings. That's not a very good smell for neighbors to be smelling. So, and so, that can happen to somebody else. And so all I was saying is, if you can afford a big, great commercial system, go ahead. But if you got people breathing down your neck and you can't afford that, this is an alternative. And you can almost do it for nothing, if you have some tanks laying around. So it's really just the cost of the tanks and then some other things on top of that. And you've got a way to clean the water and reduce. We were using, like I said, 1,700 gallons on a mow day. And, we got that down to nothing, almost nothing.
Well, let's just, let me stop you there, and Carl will wrap up in a second. But Rick, this is the thing. Even if you're going to go buy a turnkey situation, right? You can size it less if you clean the clippings off.
Exactly.
You don't need to buy as big a one. This is the thing that I like the most about this project is you can build it our way or you can go get one. But there are some really critical things that you should know, some due diligence you should do to understand how to size this thing right and effectively have something you can maintain, right? Because no matter what you got, some aspect of this system is going to require some maintenance, generally, in one way, shape, or form. So I think no matter how you go, the principles are there. Size it right. Keep the water clean. Carl, I'll pass it back to you. You get us out of here.
Yep. Thanks, guys. So Frank, people can expect a guidance document on this in the next year or so. We're going to try and develop a document that outlines all the components of this system. So, Rick, as you're talking about certain components, we're going to try and provide options at each step that can get you to something that's going to work for your facility. What size it is, whether you need to recycle water or not, those sorts of things. So expect a guidance document here coming up soon. Thanks to all our live attendees. Very familiar bunch. Thank you guys as always for tuning in. And thank you guys for watching this video with our ERP project. We hope you learned something. We'll see you guys next time.
This has been a production of Cornell University, on the web at cornell.edu.